Hello, welcome to Picture Me Coding with Eric Aker and Mike Mull. Hello, Mike.
Hey there.
Mike, this is going to be, I believe, our 75th episode. I'm surprised we've made it this far. We have two new Patreon subscribers to thank, Ralph Minderhoot and Tim Lavoie. Thank you very much for supporting our show. We appreciate it.
Yes, thank you very much.
Now, we have a special guest on the show today, Matt Teichman. Matt is host of a podcast called Elucidations, and he's a lecturer at the University of Chicago. And Matt has a really interesting and I think surprising background. It's a mesh of philosophy and linguistics and computer science, and these are topics that we are interested in, although not experts. So I think we're lucky to have Matt on the show today. Thanks so much for coming on the show, Matt.
Thanks so much for having me. I'm a huge fan of the show. It's, absolutely thrilling to be on.
That's awesome.
I should probably also mention that we know Matt through my son, Nathan, who has worked for Matt on some of his software projects, which we might talk about later.
Yeah. And I first heard the podcast when he came on. What episode was that? That was a great episode on the Curry-Howard isomorphism. I recommend it if listeners haven't heard that.
It's our third most popular episode.
Is it really?
Yeah.
I had no idea.
Yeah. I advertised it on Twitter. I don't know if that helped.
So, Matt, can you tell our listeners a little bit about your background?
Yeah, my background is completely insane, and I have too many degrees. So that seems like a good place to start because I've noticed that you all have very interdisciplinary interests. So I think maybe there's some synergy here. So in college, I was a prospective French linguistics and film major, big fan of French literature, and big fan of learning different languages. And that's kind of just what got me into linguistics because they don't usually teach linguistics before you go to college. And I was also really into 3D animation via video production is kind of what got me into cinephilia and film study stuff. So I was studying all those things in college and eventually turned into a dual major in linguistics and film. And then I started a PhD in film studies at the University of Pittsburgh after finishing my college degree. I was basically following in the footsteps of my favorite professor, Amy Virejo from college, my favorite film professor, who had done film studies at the University of Pittsburgh. And I did that for a little while. And then I discovered that there was, although I'm a lifelong cinema fan and I kind of always will be, fundamentally creatively fulfilled by making moving image works, there were certain limitations to film studies where I didn't, like the background I was trying to bring to it, it wasn't exactly a perfect match. So I ended up switching to do a PhD in philosophy. I found out that a lot of the things that I was interested in from film studies and linguistics, it turns out philosophers were writing about those. And in many cases, some of the stuff I was interested in from film, like philosophy professors were writing articles about more than film studies professors were.
Oh, okay.
And then for certain topics about language as well, there's, linguists kind of, they sort of have their methodology worked out. Like this is our curriculum, this is what we do, this is how we study languages, these are our methods. So that's very nice in some ways because it enables them to get very detailed in their analysis and conversations about certain things, a little more like a scientific field. But it also means that there's certain like questions that are really fun to think about that they just don't write papers about. Big questions about the nature of language and stuff. So all that kind of pushed me in a philosophy direction, and I ended up doing a philosophy PhD at University of Chicago in the philosophy of language. And we can, talk more about what my dissertation was about if you all are interested. But it was sort of an interdisciplinary linguistics and philosophy dissertation on the meaning of these kind of loose generalizations that we would, say in everyday conversation. And then after finishing my philosophy PhD, kind of like what happened with film, I just keep jumping disciplines. I'm like, one of these, distro hoppers. I'm like the discipline version of a distro hopper. If any of you guys are Linux freaks. So what happened is kind of like what happened in film studies is more and more of these questions that I wanted to like read philosophy papers about, they weren't really writing philosophy papers about as much. And it was like computer science people that were writing papers about them more. I started drifting more and more in that direction. And my previous, interest in computers, which had been in the background, kind of started getting more and more serious about that. And I found that to get like my philosophy freak on, I was turning more and more to what was happening in software, computer science, et cetera, et cetera. I also, right after I finished my PhD, I started learning how to program, which I hadn't really done seriously. I messed around a little bit when I was a kid in computer class.
And the language you were learning when you were first learning?
Yeah, so the first time I tried to teach myself, let's say in the phase when I was trying to seriously learn programming, where I wasn't just
Mm-hmm.
messing around as a kid, I tried to teach myself Python when I was in the middle of doing my philosophy PhD. And I can tell you, I can tell you guys more details about this because I feel like you might be interested. But just at a high level, I got totally stuck trying to teach myself Python, and I like gave up. And then a few years after that, I think it was 3 years after that, somebody who became a teacher and mentor to me at the University of Chicago Library, he started teaching me OCaml, and the exact stuff that I was stuck on in Python was just like not even an issue in OCaml. I got through that initial barrier that I had reached trying to teach myself, and I felt like I could pretty much. I mean, I didn't really know anything, but nonetheless, fundamentally, I felt like I could kind of do what I wanted to do for the first time in computer code. And then that was when I decided to maybe try to flesh out my computer background and get yet another degree. So I did a part-time master's in computer science here at the University of Chicago while I was teaching full-time, teaching intro linguistics and philosophy in the humanities core here. And then after 4 years of that, a position opened up in the library in the cubicle literally right next door to the guy here who had been my mentor. And I, could not resist the opportunity to apply for the position. So I changed gears and became a software developer at the U Chicago Library. And then a few months after that, I was starting to miss teaching. And I happened to be playing cards with not that I play cards, I'm terrible at cards. Anyway, I happened to be playing cards really badly at hack night with the director of the master's program that I just graduated from, and he sort of mentioned that there were some teaching positions opening up, and I thought, oh my goodness, I've kind of been longing to teach this functional programming stuff I've been learning to other people. The opportunity to do that part time came up coincidentally right at the beginning of the pandemic. That wasn't the plan for it, but that's when it happened.
Okay. So, what department is that in, Matt? That you teach
that I'm teaching functional programming now.
Oh, functional programming. Sorry, yeah. What department?
Yes. So before I worked at the library, I taught in the humanities core. So the University of Chicago has this like core program, which is intended to be a bunch of interdisciplinary courses that people spend like 2 years on, including some science stuff, including some social, soft science stuff, hard science stuff, and humanities. I was in the humanities core, teaching the philosophy humanities core class, and actually I was mostly just teaching linguistics humanities core class, but I would sneak a lot of philosophy into it. When I taught full-time for the humanities core. And then when I started working at the library, I started teaching computer science part-time for the master's program.
Wow. Okay.
And I've been doing that since then.
You mentioned that you encountered Stu Kurtz at Chicago. Where does that fit in?
Oh man, yes, Stu Kurtz. I'm like, if I'm going to hype anything to the maximum possible amount, it is definitely Stu Kurtz. He's an absolute treasure. If you ever have the opportunity to do anything with Stu Kurtz, I could not recommend it more. So he's a professor at the University of Chicago who I don't know a lot about his mathematical background, but he started off as a pure mathematician, is my understanding. And when he was young in his career, I think he worked on like randomness and Kolmogorov complexity kind of stuff. But I don't know too much about that period of his work. And then he was invited to found the computer science department at U Chicago in the mid 80s. Basically, a bunch of pure mathematicians created the computer science department here. And there's still that kind of tradition of computer science just is a part of math. That's just what it is. There's still kind of that tradition that persists a bit today in that department. So Stu Kurtz was one of those founding people. And I came along and I did an independent study with him when I was in the computer science master's program. The stupid reason I did it was I needed an extra course in order to be able to qualify for a student loan. But the real reason I did it was, he seemed to be working on a lot of interesting stuff. So I just kind of randomly emailed him and asked if he wanted to do an independent study. And it was, I've cold emailed people about this stuff before, and usually they're really cagey and they're like, I have all these commitments and blah, 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 blah. I don't know if I want to do it. And, I don't know if I like talking to young and smart people because it makes me feel like I'm not as young and not as smart and blah, blah, blah. It's all this nonsense you usually have to deal with professors. But I emailed Stu and it was just like 2 seconds later, he was like, that sounds amazing. Let's do it like right now. All the while he was the master of the entire physical sciences division, which is a very demanding administrative role running the whole physical sciences for the university. He was in the middle of doing that, but he still just like instantly was like, yes, let's do this. And he made tons of time available, tons of free time to work with me. And he was just so enthusiastic. He's just such a delightful guy. He's brilliant. He's got like a sort of a pure math mindset, but he's really obsessed with type theory and functional programming. And yeah, he introduced me to dependently typed programming, which previously I'd only heard about on like podcasts and stuff. I had a vague notion of what it was about, but he showed me some stuff I think I never would have otherwise been exposed to. So it was a great experience. I did an independent study with him over 1 quarter, and then I continued to attend various like reading groups that he ran and stuff, and stay in touch with him.
So I think we wanted to talk a bit about your semantics work to sort of start things off, and how that connects to philosophy and how it ultimately connects to writing programs.
I got to say, though, first, the Venn diagram of stuff that you described, linguistics and film and philosophy and computer science. Do you, like, if you go to a conference, is it just you? Are there other people at the conference? That's a pretty funny cross section of interest, I think.
I'll tell you, my favorite conference to go to is the Emergent Ventures Unconference, and it's all. There's nobody with my exact Venn diagram of stuff because there like kind of never is, but there's just about 100 people with equally weird Venn diagrams of lots of stuff, and just having conversations with people at that conference for like 10 minutes can be incredibly illuminating and put you on to new stuff you wouldn't have heard of before. So, yeah, I think that's my pick for a stimulating conference.
So you grounded this theoretical stuff for us in the work of Richard Montague. I'd never heard of him, but it sounds pretty mind-blowing, some of what he talked about and how the field of linguistics came out of that. Could you give us a little bit of a primer on that? Because there's a lot of application to what we're doing in computer science and programming and software.
Absolutely, yes. Richard Montague was this kind of amazing polymath who came up in the Bay Area in the 50s, a professor at UCLA starting in the late 50s, early 60s, who just brought together, philosophy, linguistics, mathematical logic. Linguistics was a burgeoning field at that time. It didn't really exist yet in its present form. But he kind of flipped in the 60s from the view, this was in like papers published in philosophy journals, from the view that natural languages like English, Hungarian, Chinese, etc., the languages that people speak, he originally thought that those were like fundamentally different from symbolic logic, what they call formal languages. Any computer programming language would also be a formal language like this. Sort of these made up technical languages with a simpler grammar and a smaller number of words in them. Mm-hmm. He started off thinking that human languages were like deeply disanalogous to like computer languages and formal languages. And then he changed his mind about that a couple years later and published some very influential papers in the philosophical context, arguing that actually, you know what? I changed my mind. I think natural languages like English and Finnish and et cetera, are basically just really complex formal languages, like a programming language or like a mathematical logic thing. And then he ended up essentially using a version of the lambda calculus to try to show that, like, well, if we like translate the meanings of individual words in a language like English into these lambda terms, we can show how just through regular beta reduction, and maybe we can explain what that is and stuff, but just familiar lambda calculus stuff, how these simple word meanings combine together to give you the meaning of like a whole sentence, just in the way that lambda terms and a lambda calculus are meant to combine together.
Wow. That is a mind-blowing argument I'm just amazed that this argument exists in the world, that I just assumed.
It was bold.
Yeah.
Yeah, because like intuitively, right? Language is so messy.
Yeah, so ambiguous. There's so much possibility for meaning. Even a single word can be reused, and context can change what it means. It's like, I want to be convinced in this idea.
So this just kind of occurred to me on the spot, but do you think that the LLMs, the sophistication of the LLMs kind of gives credence to his argument that real languages are formal? They're just much more complex than our manufactured formal languages?
I think it's an interesting thing about LLMs in our culture, at least right now at this moment in 2025, that people are using them to argue just for whatever they want. Like, it's evidence for P, it's evidence for not P, whatever the context is. Look, look how great ChatGPT is. Therefore, whatever my view is true. But so, I mean, one thing you hear a lot is that LLMs vindicate a view in philosophy called inferentialism, which is the idea that all natural language meaning is a version of like a version of a deductive argument of the kind you would have in a math proof. They're not as strict as a deductive argument, but like that, an inference of that, inference of that kind. And the idea there is that you can actually explain a lot of our reasoning including some of the reasoning that you would have thought was just like sense perception, as just more logical inference, and that the LLMs are vindicating this because they can understand so much about the world without sensing anything. They're just scraping data off the internet or from their training data. So I haven't captured that argument. In terms of do LLMs provide support for Montague? I'm not sure. My gut reaction is that they're sort of coming from two different traditions. So Montague is really coming from this traditional mathematical logic background, a little more like the symbolic AI half of AI, and then LLMs are coming from the sub-symbolic half of AI, where we're not thinking in terms of high level rules. Like the rules of chess or something, but rather we're just extrapolating statistical patterns. So I would think, if I had to guess, I would guess that people who are cranky about Montague would say that the success of GPT supports their view. And you have seen this a lot, probably, maybe you come across this in the news media about, you've heard maybe people say that, oh, look, ChatGPT refutes Chomsky. So
I haven't heard that.
Chomsky and Montague are sort of they wouldn't have been voluntary bedfellows, but they ended up being kind of bedfellows in the way the discipline coalesced. Because if you're a linguistics major, you learn the Chomsky stuff for syntax, and you learn the Montague stuff for meaning, for semantics. But I guess that's my gut reaction. Is like, yeah, if you're in LLM land, you're not writing the LLM to think like a regular computer program. You're writing it to subtly influence how the system gets trained to give you a black box that will behave in a certain way, hopefully, or
So, Matt, in trying to understand the claims that come out of Montague's work here, I was looking at the Stanford Encyclopedia of Philosophy entry that you pointed us to. So I started reading it. They have a quote in there from Montague, which really struck me, where he wrote, "There is, in my opinion, no important theoretical difference between natural languages and the artificial languages of logicians." It's such a strong pronouncement. He says, indeed,
he's putting it right all out there.
"I consider it possible," he writes, "to comprehend the syntax and semantics of both kinds of language with a single natural and mathematically precise theory." It's just kind of mind-blowing to think you can encode natural language into mathematical formulas. Like, you really could achieve that. Is his argument it is possible to do that, or his argument is not only is it possible, but I will show you the way. This is what it looks like. If you take any statement, any sentence in a natural language, you can mathematically encode it in this way. And how do I make sense of this claim? It just I have trouble like just swallowing this at face value.
Yeah, I think it was definitely a time period in which people were prone to bold claims about what computers might be able to do in the near future. I'm reminded of what was it? Was it like Marvin Minsky or McCarthy or somebody hired a grad student to write code to generate descriptions from images, and they're like, "Oh, they'll just do this as a summer project," and then like 50 years later, we still didn't have it. That's kind of what this remark reminds me of. So what Montague actually did, it was he what did he give a constructive proof of, as it were? Well, what he gave a constructive proof of was, if you take this tiny fragment of English with only these 10 words, I can show how that is like a formal language. And then I can just tell from my, I have a gut feeling that we could just keep going with this and eventually get all of English.
Okay.
I think that was sort of the way he was thinking about it. So it's still a pretty bold claim, but he also didn't not do any of the work. He showed how, you could sort of analyze fragments of English in this way. And that was enough to convince linguists, maybe this is part of the history we should talk about. So shortly after he published this influential work, and the quote that you read is from, right after he kind of completely changed his mind about this.
Okay.
He was murdered shortly after publishing a few kind of amazing papers in this area, and it was his whiz kid student Barbara Partee, who ended up taking his actually pretty difficult to read papers that were written in sort of dated mathese combined with idiosyncratic philosophical jargon and views, and they're you definitely got to do some work to understand them. She took his work because she was his student and worked with him closely, and translated it into terms like the lingua franca, the disciplinary lingua franca of linguistics, and actually just, went on the conference circuit and sold this as like a new subfield of linguistics to professors.
Is that semantics? Because you use the word semantics.
Yeah.
So that's the field that we're talking about. Subfield of linguistics is semantics.
Yeah, so if you go to college and major in linguistics, they're probably going to make you take a course, and they're probably going to make you take like 5 or 6 courses. They'll make you take semantics, they'll make you take syntax, phonetics, and phonology, and then maybe
Okay.
like field methods and historical linguistics or something roughly
Oh,
like,
okay.
or maybe sociolinguistics.
Okay.
But
Okay.
so it's considered to be one of the major subfields of linguistics now, thanks to this work of Montague's student. Montague also had 2 other very influential students who were pretty interesting as well. One of whom has been on my podcast, Hans Kamp. But maybe I won't go into him right now. But if we want to talk later about like imperative versus functional programming, there's a place where he would maybe be relevant to talk about.
It's surprising because I was again reading about Montague's background, and he's got as a logician, he's like specialized in set theory and modal logic. I was like, well, that sounds kind of familiar. And then he's talking
Yeah.
about meaning in language,
And he's at
maybe meaning is
UCLA, where Dana Scott and all. There's a lot of big time mathematical logic happening at UCLA.
so building like this mathematical concept of semantics. It seems like a very, like you said, it's a bold claim, but
Yeah.
then it relates to programming. It relates to lambda calculus, as you brought up. It relates to functional programming. This is like it's like this kind of car crash in my brain of, wait a minute, I
Yeah.
thought these
Me
things
too.
were separated and they're like mashing together, and now
This is
the
exactly
crumple
what happened
zones
to
are
me when I
embedded.
learned OCaml after doing my PhD. I started learning OCaml, and I was like, wait a minute, this like thing I used to analyze language, you can make your computer do stuff with it. And then so much carried over from one to the other, like, these type lifts that I was just doing on paper in my dissertation. It's like, oh, I'll just define a function to lift the type of this to this, type that takes a function input. And it was like practically the same thing I had been doing in philosophy, but now I was like making my computer go. Totally blew my mind.
So Montague's work sort of morphed into this part of linguistics, but is it still part of philosophy? Is it something that people still discuss in academic philosophy now?
Yeah, I think it's there's been a lot of pendulum swings as far as that goes. So there was starting to be interest in what linguists were doing in natural language semantics in the 70s. So a philosopher you may have come across named Peter Geach, very interesting fellow. He was pretty serious about natural language semantics. Another famous philosopher from that time, David Lewis. You may have heard of him in connection with his view that merely possible worlds exist, though they don't exist actually. Anyway, he's a big philosopher from the 70s. So he was also invested in natural language semantics. I think around the late 70s to the 80s, the field kind of pivoted away from engaging with linguistics. And then it wasn't kind of, just, what academia is like, just trends happen and they take over and everybody forgets about what they were supposedly really interested in before. It's the same in tech, right? The AI springs and AI winters. Yep.
I didn't realize academia was like that. I thought it was pure intellectual activity. You follow
That's all
the truth
propaganda.
where it goes.
None of that's true.
That's propaganda.
Yeah, they've done an incredible job of selling that lie to people who are not in academia.
I bought it as an undergrad.
Yeah, no, and undergrads are the prime customers for that complete lie.
Oh, okay. Okay.
And I bought it as well. It took several PhDs, one of which was completed for me to learn the truth. So then in the late 90s, I would say, and then slowly creeping up to when I did my PhD, I started my PhD in 2007. So from late 90s through the 2000s, there started to be more and more engagement with philosophy, with linguistics amongst mainstream American philosophers. Part of this, interestingly, was there was a whole other philosophy scene in the Netherlands that was associated with intuitionism, which is maybe a topic of interest to you all as functional programmers. There was a whole philosophy scene in the Netherlands where they never lost their connection to linguistics. So that sort of happened in parallel, a bit disconnected from the American scene. And kind of my take on what happened in the 2000s was the Dutch philosophy scene, which was just full throttle engaging with linguistics and pure math, and this kind of fun intuitionistic tradition. They kind of converged again in the late 2000s. So the American philosophers started re-engaging with the Dutch scene. And part of how I got interested in all this stuff as well was I did a year abroad in the Netherlands when I was doing my philosophy PhD. So I was exposed to some of the Dutch perspective on this, which conveniently for me is all written in English.
That is convenient.
It's quite convenient, yeah.
Yeah.
They're all, and it's really brilliantly written too. I mean, yeah, I mean, I guess it's no secret that Dutch people are really good at learning foreign languages, but like they're amazing at expository writing of like difficult technical material. They're really if like if you're just trying to get the lay of the land in some challenging mathematical topic. I recommend the writings of Dutch logicians. Incredibly clear and sane the way they present things.
That's a surprising note there.
Yeah. Yeah. So I think it kind of came back in the 2000s, and now the disciplines are sort of working together again. But it's been kind of on and off, I think, since Montague passed away, since the 70s, I guess.
So you teach functional programming, you have an interest in functional programming, and your interest comes out of the philosophy, it comes out of the linguistic side. But I'm curious, what is it about functional programming that you find engaging or interesting or useful?
Yes, very big, important questions. Well, let's see. What does I like about functional programming? Well, so I should say that I think I alluded. There's like I don't know. In my brain, I always think of there's those two halves of everything. So like in AI, there's symbolic and sub-symbolic. And in functional programming, I feel like there's like typed functional programming, and then there's like all the Lisp and scheme and stuff. Incidentally, I've been trying to learn Emacs Lisp a bit recently, and I find it very, very challenging.
Yeah, that's not that fun.
Yeah, it's tricky. It is very interesting, I think, though. But it is one of those things where I feel like it's as different from working in a flavor of Lisp with full homoiconicity. I guess I should say what that is. The funny property that Lisp languages have, where they're sort of metaprogramming, I'll just call it. Getting accustomed to writing in the Emacs style for that language, to me, is as different from OCaml and Haskell as OCaml and Haskell are from whatever. JavaScript, Python, normal programming.
I guess the thing I wanted to get at is why, when you reflect back on, you try to teach yourself Python, why didn't that work? Why did OCaml work? Was it a feature of the language, or was it a way of thinking? Because you said that your background sort of primed you to be ready to receive the computational thinking that was emerging in OCaml for you.
I can tell you about my experience, and I think my experience makes a lot of sense to me, not surprisingly, and I think it's for some reason different from a lot of programmers' experience. So maybe I'll tell you about it. You can tell me if it's different from your experience. So I tried to learn Python when I was in philosophy. I was going off of a friend of mine's lecture slides, and he's a great programmer. But I wasn't pestering him with questions though, so I was just trying to teach myself from his slides. And do you guys remember the Animal program? So I grew up in the 80s, and my childhood was in the 80s, and that's all. Whenever all my warm and fuzzy feelings, associations with computers are with the 80s. So the Animal program was popular when I was in first grade, and so just for nostalgia reasons, I thought, let's write this Animal program. So actually, you want to? It might be kind of fun. Do you want to be the user and I'll be the program? I'll just explain what the animal program. Okay, so all right. I'm the program firing up now. Think of an animal. I'll try to guess it. Does it have legs?
Yes.
Is it a horse?
No.
I give up. What is it?
That was pretty fast. I thought tiger. First thing I thought of was a tiger.
Thank you. Please enter a question that differentiates a tiger from a horse.
Oh, interesting. Does it have stripes? Probably would be my question.
Thanks. Let's play again. Think of an animal. I'll try to guess it. Does it have legs?
I never played this. Mike, did you play this game? Do you know this game?
I honestly don't. I've seen a variant of it where it asks questions and it guesses what movie you're thinking about. But
that sounds like the same thing, basically reskinned. Yeah.
Does it remember? Does it save the questions?
You type the question in. And then it has this knowledge base. It's basically a form of a decision tree about whether you answered yes or no. And then you kind of insert the question into the tree after the question about does it have legs, and then it will then ask that. And then you can keep playing the game. And when I was 6 years old, I had a version of this for Logo, and I had a version of this for Basic, I think. And I would play it for 3 hours and would put all these animals and questions in. Fantastic. So I thought, I'm trying to learn Python. Let me try to teach myself to write this program. So what did I do? I didn't look at any computer science, anything. I was just made up in my head, I'll encode the tree as this list of tuples of what, I don't remember, something like that, strings. And what happened was whenever I tried to recurse into the tree, I didn't really know what recursing was. I was probably doing some half-baked combination of recursion and while iterating over the leaf nodes of the tree, I was just getting all these index out of bounds errors. And I was total beginner. Now I know how to like suffer through that and debug that kind of code with out of bounds errors. But at the time I had no clue, because I'm like, I have 3 different functions. They're calling each other, and somewhere in there's an index out of bounds, but I don't know where in the tree, the question tree, the index out of bounds happened. And I had no idea how to debug it, because I didn't know how to debug anything. And I was like, completely lost. I didn't know how to fix it. Whereas fast forward 3 or 4 years, I'm learning OCaml. Well, in OCaml, you define a data type for the tree just with a simple type definition. And what you do is you pick a data type that exactly fits the structure of the tree that you need. And then you can just recurse into it, and voila, no more indexes to ever think about. It's completely length agnostic, completely index agnostic. The recursion into the tree to pick the next question is just what you would think it would be in English, without trying to translate it into, is it n or n minus 1 or n plus 1, et cetera, et cetera. You just never have to think about that. I think maybe it's that I stumbled into a program that kind of is calling out for a recursive code to work. But I found it just like so much easier to do in OCaml than in Python. And I did notice like one difference, like when you write something in Python, the first version of what you write in Python runs just fine. And, the first version of what you write in OCaml, you get 50 type errors and you have to rewrite it, at least 10 times before it even compiles. And I assumed when I first started doing this that, I'm just a beginner. I don't know what I'm doing. That's why I keep getting these compile errors. But I later found out that no, that's what's supposed to happen. You're supposed to just keep getting it wrong until it comes out
type Tetris.
A little closer to working.
Exactly.
Yeah. And so I didn't really appreciate it at the time, but I think the compiler was actually doing a lot of work for me, statically checking that there weren't really dumb errors in the code everywhere.
Yeah.
And there were definitely some things I struggled with, like sort of side effects and light bindings I struggled with the most, I think, when I first started learning OCaml.
So I like how you grounded it with recursion. Like recursion was a tool that kind of made intuitive sense to you once you realized you had a name for it. You had this concept. It's sort of like there was a proto version of it already that you understood. And maybe
and
like
I'd encountered it before in philosophy
like
and logic stuff. So it wasn't completely out of the blue hearing it for the first time.
So I guess in terms of like actually building recursive
evaluation. Right, my first time building recursive stuff. Yeah.
That's pretty interesting. And I mentioned this question to you, but over many years participating in the Haskell community, we would get people coming to places where Haskell programmers were congregating, social media or whatever, and they were coming from other languages. Most commonly, they would have first learned JavaScript or Ruby or Python or Java, and they would say, I want to learn Haskell. It sounds interesting. People say weird stuff in Haskell. So they would come.
I encourage that.
They would come to the Haskell community and they would say some version of, why is this language so difficult to learn? And not as a majority response, but a very common response was, it's difficult to learn because you first learned imperative programming, and that is your mode of thinking about how to solve programs, how to do computational thinking. It's like you have these imperative models in your brain. And if you had first learned functional programming, it wouldn't be as hard. And I don't want to like outright dismiss that argument, but it never quite, like it was an unfair counterfactual. It was like a comparison I didn't think could be made. I didn't really buy this, but you're like a real world example of that. You first learned functional programming, and those people are very rare, I think.
Yeah, and I'd messed around with Python, and when I was a kid, I'd messed around with basic, QBasic logo and stuff. So depending on exactly what you count as first, but certainly my first attempt to really, really be able to really write programs, I guess what you could say was I had a failed one in Python and then a successful one with OCaml. But also I had a teacher helping me in the OCaml case, and I didn't in the Python case. So could have gone differently.
When you're teaching functional programming, do you have this? Does this occur to you? Like, certainly, some of your students come to your classes with experience already and programming and other paradigms.
Yeah, some of my students are very experienced. It's a funny thing of the master's program here that you are actually allowed to apply, and you may get admitted without any computer science background. So it's perfect for me at the time that I did the program. And I've had quite a mix of people. I've actually had a lot of philosophy majors who've never done programming before, jump into my class. And I would say anecdotally, there's like no correlation between prior experience level and how hard people find my class.
Oh.
So yeah, so some people who are really experienced can like slot the Haskell style very easily into what they're familiar with, and just they have no trouble. And some people, their prior experience kind of gets in the way, and then so
Mm-hmm.
too for people who are very new. Some of them struggle, and some of them are like wizards with it. So I don't know if that's different about Haskell versus other kinds of computer science classes. But I have noticed that I cannot find any systematic correlate. I cannot find any indicator of who's going to find it hard.
Yeah.
But I definitely have stuff I do with the people who do find it hard. Methods for dealing with it.
There are aspects of Haskell that make it more difficult than other programming languages, like printing to the screen is harder than it is in
Yeah,
Python.
I know.
Or
It really gets in
virtually
your way with or well, I don't know, depending on your definition, getting in your way. It definitely gets more up in a beginner's face if you want to do IO.
Well, and every time I've ever taught anybody to program, there's the theoretical computational thinking part of it. How do we solve these puzzles in our brain? But then there's the physical, actual, I have to type in something somewhere and I have to figure out how to run it, which means I probably have to have a terminal. And there's all this sort of like real world junk. I have to actually run the program. And if I'm talking to somebody who has no experience with the terminal, they're immediately like, what is this interface even mean? Like, where am I? What am I doing? It's
What's
just
the
me and
path?
text.
Why am I getting these errors?
Yeah.
I didn't get the error 5 minutes ago.
How come this binary doesn't exist? What is a binary? And so there's like things that get in the way of just purely solving programming problems.
Yeah.
Anyway, do you find what do you think about this question? Like, is functional programming, is it more difficult or just a different paradigm than imperative programming? I just don't find it very satisfying to say, well, if you learn that first, it'd be a lot easier than having learned it second.
Yeah. So, certainly I have bad incentives pressuring me to believe that story. I like to promote functional programming people, and I like to encourage my students not to think of it as hard, because how else are you going to, you're not going to learn it if you just, if you're all scared of it. And I go to great lengths in my class to really make this a functional programming class that you can just, like, normal people can just do. Like, you don't have to be a math super genius to get through the class. And that is an issue historically that a lot of functional programming classes have had, because I think often due to just the intellectual interest of the professors, they're like, well, the main thing I'm interested in is, co-algebras. So I'm going to like focus on that in my intro Haskell class, But yeah, I really try to make it into like a normal ass computer programming class that is in this language.
Okay.
And I give people a taste of the fancy theory, but we're not really, it's not on the exam, it's just sort of background. And the stuff that we cover in the class really is practical programming. And I do get students who are interested in the fancy theory, and then I refer them to stuff. But that's not really the focus of like what I actually teach.
The legacy of Haskell can be kind of a lot of burdensome too, because it is a research language. So people will go and implement their own research in that language.
Oh my goodness gracious! And you get all those language extensions.
Exactly. You end up with like 400 language pragmas at the beginning of your, not 400, I mean, it's exaggeration, but you have like, it's like, what are we turning on here?
Every one of which is a different half-assed version of dependent types with clunky syntax. Yes. So I think my take on is functional programming hard is like somewhat cranky. So please feel free to push back. But my basic take on this is that I don't think it's hard. Although let me say actually first that I agree with your intuition that this thing that functional programming people say is like not at all. There's no evidence for it. It's like empirically unmotivated. Like we don't have a sample of people who learned it first to be able to clearly say it's easier to learn it first. So I definitely agree with that. On the other hand, I think I think maybe you could use my class as evidence that it's no harder than other stuff in computer science. So if you just take any topic that you guys have covered on this podcast, you guys cover really hard topics in this podcast. Distributed consensus. I mean, come on, people do PhDs in that. It's really hard. Low level amazingness that Mike covers in his How Does My Computer Work book. I don't follow everything there. There's a lot of little details and fascinating stuff. It's very challenging. It's just like, we just think about like, there's all these C puzzle books. Like, how could there be an entire genre of books that are just puzzles where what is this code going to do? And read it and tell me what this code is going to do. How could there be this whole genre of puzzle books for C? If it wasn't hard to to learn all that. I just think computer science is hard. And often what happens when people complain about when functional programming is too hard is I think there's this tendency sometimes in tech for, you to develop expertise in one thing and then, and then kind of be like, well, that's it. That was so hard to learn. I don't want to learn anything again.
Oh, I'm
that
done.
took 20 years. I'm all done now.
Yeah. I think I understand the tendency you're referring to, and it always kind of annoys me when you have people who are really good programmers who are like,
"Oh, you mean I got to learn a new thing now?"
Yeah,
I spent too much time on this other thing. Why can't we just use the whole thing?
Now I will analyze the real estate market for you because obviously I'm an expert in writing programs, and it's so easy for me to just become expert at everything, and I will explain everything to you now. And that always kind of annoys me a little bit.
People I think they can get if you're really experienced in whatever the computer thing is. If you're really experienced in whatever the computer thing is, you can kind of get cocky and feel like, oh, it's not my years and years of experience and familiarity with everything to do with this that's making me good at it. I'm just good at picking things up quickly. I'm, clever and sharp and fast and stuff.
Maybe that's my problem is I just assume I'm really bad at this and I just got lucky.
No, that is, I got to tell you, every single person I've met who is a legit ass computer expert has that attitude.
Really?
Yeah, because otherwise you block yourself from learning things. I feel like.
Oh yeah, you got to stay critical, right?
I guess.
When you think of functional programming, it is true that if I learn how to do a while loop or a for loop in C or Python or whatever, and I think I want to learn Python, I want to learn Haskell, and I want to solve a problem. I want to learn Haskell by solving a problem. How do I do a for loop? And somebody says to you, "There isn't one."
Yeah.
Then you go, "What?" That it does. It sounds different.
Yeah, and also I think part of the language about this that people use to talk about this is confusing. So many programming languages have the same syntax for defining a variable and mutating it, mutating a reference cell in place. That must be the exact same syntax. And I think you get used to writing x equals blah 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 to mean different things, but it looks the same, and you just think of it as the same thing. And they can be hard to pull those things apart because the language itself is so visually ambiguous.
Oh, interesting.
That's also kind of part of it is some of these languages introduce distinctions that you may not be used to thinking about from other languages.
So I have kind of a parallel question here, which is I know at least 3 people, the 2 of you and my son Nathan, who have come to computer science through philosophy. So Nathan's degrees are in math and computer science, but this is also a person who was fascinated by Bertrand Russell when he was 18 years old. So he kind of liked both the philosophical and mathematical aspects of mathematical logic. So what I've found, what surprises me with all 3 of you is that you kind of converged on the same parts of computer science. So you all are fascinated by functional languages. To a certain degree, you're all interested in formal methods. I think the semantic stuff plays in here too. Nathan's always talking about, denotational versus operational semantics and stuff like that. So,
and compositionality, I think, is an equally big word in computer science and linguistics as well.
Composition, I wanted to get to that too. Go ahead, Mike.
Right, okay. So I'm just wondering if, I feel a little bit different than the 3 of you in the sense that, when I started out working on computers, it was like, I want to make stuff show up on my screen, or I want to make my printer make characters and stuff like that. And so is it just...
I guess animals.
Yeah, I guess animals. Is there a sense in which you think that the philosophy background sort of leads you? Is it the same intellectual space there, or is it just a total coincidence that you guys have kind of arrived at the same interests?
Yeah, this is a very deep question. So I'm not really sure what the correct answer is. I have sort of a conjecture answer to it, which is that I think philosophers and programmers in different ways both have to wrestle with what in computer science we call side effects. And you can think, I have a whole thing in one of my lectures on what side effects are, but you can think of it as something in the background of the program that you're writing, interacting with the behavior of the program while not being actually in the code for the program. It could be mutable state in the background, global state, or it could be, some sort of IO, writing to disk, reading off disk, and
launching the missiles.
Launching
Sorry,
the
go ahead.
missiles, that's the classic one. Yeah.
That's like a Haskell example.
You can tell what era people started writing about this from what the examples they use. Yeah, launching this feels like James Bond of the '80s or whatever. Cold War. So I think programmers have to wrestle with side effects, and a lot of the techniques that people have kind of like software architecture or design principles people come up with have been just various versions of like how do we keep the side effects from preventing me from debugging my code. That was a weird way to say it, but how can we kind of like gather together all the side effectful parts of the code into this one place, and then keep this other part of the code base free of side effects so as to make it easier to test and find bugs? There's kind of a similar situation that arises in philosophy where you get these weird effects on meaning when you're making an argument or reasoning that are also side effects. There's been a little bit of research into the analogy there, and some people have made it in some detail. I guess one example might be anything to do with there's this area in natural language science called dynamic semantics, which is actually explicitly intellectually kind of based on the imperative programming, where you have a machine with a state, and then the logical formulas already are interacting with the state of the machine in some way. There's all these dynamic effects of saying something that are not part of like the words you're saying. So maybe one simple example here would be, you might have presuppositions in the things you say. So if I say, my daughter is currently playing in the playground, then that sentence presupposes that I have a daughter. So you can only say that in a context in which it's part of the common ground of the conversation that I have a daughter. And if it's part of the common ground of the conversation that I don't have a daughter, the person I'm talking to, like the program's going to crash. The conversation program's going to crash. The person's going to be really, well, wait a minute. They're going to do this thing where they halt the real conversation and have a meta conversation about, wait a minute, you have a daughter? What? You don't have a daughter.
Wow. It's so weird for me to try to allow conversations and linguistics and language and meaning and to come together in the same room. Every time you make that bridge, I'm like, wait a minute, what?
Yeah. And they come from a kind of you could argue that they historically come from a similar place, which is the work of Gottlob Frege, turn of the century philosopher and mathematician. So like another example of a linguistic side effect that he was interested in is referential opacity, which programmers are also very interested in. They talk about, referentially transparent code is sometimes called pure code or code that's free of side effects. And there's a similar notion in natural language of, so let me see if I can get the Frege type of example. It would be like Superman walked into the room and said hello. That sentence is true in exactly the same situations that the sentence Clark Kent walked into the room and said hello is true. So you can substitute names that refer to the same thing without changing the truth of the sentence. But the sentence, Matt believes that Superman walked into the room and said hello, does not mean the same thing as Matt believes that Clark Kent walked into the room and said hello. So Clark Kent versus Superman are kind of interchangeable when they don't come after this word believes. But when they do come after the word believes, suddenly they play a different role in the meaning of the sentence. And you can draw a direct analogy between the situation that you come up like stuff like that in language and stuff you come up with in code, where I'm like, why is this a false assert? I ran this code a million times in this context. I moved it over here in this other module. Why would that change the behavior of the program at all? But it does. It makes it crash. And it turns out, there's some hidden global state that I was carrying around that I didn't notice. I forgot about. That was established over here when this thing launched. So my conjecture is that the answer to Mike's question might be philosophers and programmers are always wrestling with weird behavior as a result of side effects. And functional programming gives you a series of techniques. I mean, it's not really a series of techniques. I would argue that functional programming is just like, let's think about side effects.
Yeah, here's a big, bright circle we're going to draw around them. So you're aware of them.
You'll be aware of them, yeah. And so because philosophers and programmers both have to be aware of side effects, I think that could be why philosophers are so into functional programming, and programmers who are into functional programming are into functional programming.
I really like your answer, Matt. Talking about side effects, I was really surprised when you said, well, philosophers are interested in side effects. I was like, what? They are? But I really believed what you were saying. I mean, your argument has convinced me. If I were going to try to come up with just sort of a, off the top of my head response to what Mike was saying, I would have started talking about, well, I like precision. Philosophers are interested in precision. Precision helps me maybe exclude things that I don't want to consider all the variables when I want to try to solve a particular problem, because I want to precisely aim at something maybe and know that I've I've said something that's accurate. I've said something correct. This is not a very, obviously very astute. This is my vague how I'm trying to think about Mike's. But your analogy to side effects is a really, really fascinating analogy to me, and it makes a ton of sense.
And I should mention, I stole this from a brilliant, also kind of polymath dude named Ken Shan, who's a computer science professor, I believe, at Bloomington now, University of Indiana, Bloomington. So his dissertation was on this topic, and there's been some work in that area since. But I think he's a font of all sorts of amazingness in philosophy, linguistics, and computer science.
I read the first couple chapters of the textbook. This is not necessarily meant to be included in that. I just got sucked into it. I was like, I want to read this book. But I started as I got deeper into that textbook, I got a little more lost. The first couple chapters I was doing all right.
What did you think of can I ask what you thought of the explanation of currying? Because that's where I first encountered currying, was in that book.
Was that in the first two chapters? I might not have
remember now. It's either
far
chapter 1 or 2.
I wasn't in chapter 1. Chapter 2, they started talking about Phrygian programs. I loved the sentence they're diagramming is Anna smoke. Is this from Phrygia? Yeah. Like, what's with this question? What's with this statement?
No, there's these like weird examples that somebody came up with spontaneously in a paper in 1963, and they just keep using them in a historical era where they don't like kind of make sense anymore. There's a lot of
it's like Anna smokes. It's like, geez, it's not really the sentence I would have picked it down. But okay, it doesn't matter. It doesn't matter.
And like, I mean, if you look at linguistics papers, everything's like John and Mary, but that's like in the 50s when they started writing about it, all the examples were John and Mary because that's what everybody was named back then. But they're still doing John and Mary.
So your comment about side effects, really surprising, but I find it convincing. I find it a really interesting way to bridge these concepts, to bridge philosophy, to bridge computer science. It's an analogy that you can see emerging in both places. I guess I think a lot about how many things do I have to hold in my head, and maybe side effects fits in there, because if I have to hold side effects in my head, they are not
your head's going to run out
deterministic. It's kind of this random grab bag of kittens I also have to remember are out there.
Yeah. And personally as well, I love like I love just like messing around on the computer. And this is what in a way I was kind of trying to do this when I was teaching myself Python. If I'm reading some really confusing paper with abstract math in it, I often like to just try to code an example up and see what happens on the computer, just as, in order to have just a sandbox to actually interactively play with the idea that I'm reading about to try to understand how it works. Anyway, that method of understanding clicks better for me. And I've heard other philosophers say this as well. One example, I think, is the great Haskell developer, John McFarlane, who's a philosophy professor at University of Berkeley, has remarked that he'll be reading some really hard to follow, fancy new non-classical logic paper, and then he'll just like whip up some Haskell to just try to understand the paper as a tool for right. So John McFarlane authored the tool Pandoc.
Pandoc, if you've ever heard of Pandoc, a very venerable, widely used tool. That's his.
All maintained by one person while being a philosophy professor. Who knows how he? Who knows how he's the time for that?
I was pretty surprised because I'd heard of Pandoc before I heard of him, and I was like, "Wow!"
Yeah.
So one connection that we have to you is that my son Nathan worked for you, or I guess he still does work with you a bit on some of the software that you work on for the library. He worked on a thing called attachment converter. So I'm just kind of curious about like what sort of software do you write for the library? What sort of tools do they need? And the stuff that your team is doing now.
Yeah, so this is one of the most exciting things I work on at work. Excited you asked about it. So my group, the Digital Library Development Center at the University of Chicago Library, which is, I had mentioned before, it's where my computer guru also works. So he and I, we work together with each other on just like building up kind of basic systems, maintenance, dev environment stuff. I have a few OCaml tools to just, like spinning up a project and, configure your editor, getting the code formatter to be a Git pre-commit hook and like all this kind of stuff. And then we also have a few repositories that we run for our internal software libraries. One funny thing about OCaml, which I guess we haven't talked about too much in this podcast. One funny thing about OCaml is that the culture, it's very much a DIY culture. So it's like kind of a batteries not included language.
Mhm.
The idea is, traditionally anyway, OCaml, you just write your own standard library out of the couple things that come in the actual standard library, and that was just sort of the attitude of the people in France at INRIA who made it, because they're all absolute badasses. Now that the language is more popular, there's a couple widely used third-party standard libraries that are more batteries included.
Oh, I didn't know that.
Yeah, it's interesting how the culture of the language is changing a bit now that more people are using it. But my guru at the library, he wrote a standard library called Prelude, named after Haskell's Prelude, that really has a tremendous amount of stuff in it that you need for your day-to-day that doesn't come with the language. And then I wrote an add-on to it that I call Etude, which is basically all the stuff that I missed from Haskell that I don't have in OCaml. I put into a library and it's meant to work with that Prelude library.
Do you have some examples, stuff you missed from Haskell that you put in there?
Yeah, so OCaml doesn't come with a way to automatically derive, like in Haskell. One of the things that's nice with Haskell is it derives. It saves you from having to write a lot of boilerplate, because it automatically derives a bunch of stuff for you.
Oh, okay.
So
Right.
if you, for example, we haven't really talked about monads, but if you never heard of monads before, just pretend it's an OO pattern. So you can define a data type, and then you just have to define two functions on it. They're called pure and bind. And then you will be able to use monadic. You'll be able to do all monad stuff with that data type, and use a certain kind of special syntax. But in addition to special syntax, Haskell will auto-define like 20 different functions just based on your definition of pure and bind. Because of the mathematical properties of monads, it turns out that once you have pure and bind, you're guaranteed, no matter what the underlying data type is, to have sensible definitions of all of these other functions. So I have some stuff in my Etude library to give you that. So just for one example, if you define your own data type and it is you define these monad functions on it, it will auto-derive the applicative functions, the canonical applicative functions for you.
Okay. And functor, and you got
that
the whole
kind of functors as well. Yeah, there's ways you can reduce monads to applicatives, and ways you can reduce applicatives to functors and monads to functors. There's two ways actually of going from monads to applicatives, and one of them nobody ever uses. That's a fun little rabbit hole. Not for today.
Yeah.
But so that stuff is very handy, because some older OCaml libraries actually will have they'll have come out from before people discovered applicatives. The command line library, which is a great command line parsing library, is an example of this. The author kind of independently invented applicatives, but the paper hadn't come out yet when the library was written. So it's often very handy to just give that data type from that library to my Etude library, and then it'll just auto-generate 17 different applicative functions from that third-party library that I can just use. They're very handy to have around.
Matt, I gotta say, if somebody said, "Hey, I work at a library at a university, and we do write software," I would be surprised to discover A, it's a OCaml, and B, we have a lot of the functional programming paradigms, and we've got monads and applicatives and stuff. Can you describe a little bit like the day-to-day, like what is
right? So the actual software that's not just libraries for our internal.
Yeah, no, I'm curious, like what goals you guys, what problems are you solving in library science or writing programs for the library?
Yeah. So there's a lot of that's a good point. I wasn't really answering Mike's question. So I'm really excited about the software that we write, and Nathan works with me on this. The software that we write for archivists. Now, traditionally, an archivist, the way the spiel I like to give is, okay, Milton Friedman kicks the bucket. Now, Milton Friedman's estate traditionally would give the contents of Milton Friedman's office, for example, to our archivists, in case researchers want to write a bio of Milton Friedman or something, and they want to go through the archives. More and more these days, what gets donated to our archivists by various fancy people's estates isn't just physical objects, but it's like hard drives. And then our archivists have to go through the hard drives and think about, like, all right, what on here do we care about? What is potentially of interest to researchers? What do we not care about? What kind of metadata do we want to give to it to make it easy to query and get at? And it's interesting. They have a whole the archivist community has developed this whole set of like best practices for determining what is of interest and what's not of interest. It doesn't necessarily correspond to your intuitions. Like, so I've had in a lot of situations where I think of something as some transitory file. It doesn't even matter at all. And they're like, no. Historians might want to know about this later. We're going to save it.
Right. Here's a grocery list from 1972 written by this famous logician. Let's see what they were buying.
Another thing I think is really awesome about the archives software space that is not true of most other software I'm familiar with is that we're always thinking about things on really long-term timescales. So we're thinking about like, hey, how is Indiana Jones 100 years from now going to be able to going to be able to open a file that we have?
Mm-hmm.
And, a lot of tech companies these days, they're doing amazing stuff, but they're caught up in this like VC funding cycle where they're going to build out a platform for 3 months. They get purchased by Google and they get shut down. So it's in the archive space, you're often thinking about like it's not necessarily about like what's the world's blazingly fastest technology to use, but it might be like, what's the technology that has the simplest spec that we could write down in English? And then if a disaster struck, Indiana Jones 100 years from now could look at my English spec and re-implement it and then load the data that I have.
Wow, that is interesting. Yeah, different kind of problems. Wow.
Yeah. So this attachment converter software is specifically for emails and specifically for attachments in emails. So let's just go back to the Milton Friedman example. Our archivist, this is a fake example. I don't actually know where Milton Friedman's actual emails are. Anyway, we do have his Nobel Prize in our archives, though. I've fondled it. We're going through Milton Friedman's emails, and he emailed somebody a Word doc. Well, are we going to be able to open a Word doc 100 years from now? Who knows? It's very popular right now. There's a lot of support for it now, but these things can be fleeting. So what the archives community has converged on is there's sort of a set of standard formats that they have agreed to support indefinitely into the future. So the current archivists, grandchildren or whatever, will be like, yes, we will be responsible for maintaining software that can read these exact formats. They're called preservation formats. And so what the software does is it goes through a mailbox and it finds all the attachments that are on its list of file formats it knows about, and then it will convert that to some preservation format. So to take the example of a binary Word doc, if it finds a binary Word doc as an attachment in an email mailbox, it will convert it to an archival PDF, which is a subset of the PDF spec that's more manageable than the full Byzantine PDF spec, and then maybe plain text. Plain text, like ASCII encoding is like very simple. You could just totally write that down on a piece of paper, and aliens could figure out how to decode it, probably.
That is really interesting. Yeah, I'm surprised by that.
So then it converts each attachment to some preservation format, and it takes the new file and it puts it back into the original email as if it was an additional attachment. But then the file name would be like underscore converted by attachment converter on the state, and we put also like some headers some MIME headers in the attachment as well, in case anybody's looking at the email and they want to know which was originally there or not. But this way we keep the conversions and the original emails in the same place. So theoretically, Indiana Jones of the future, who doesn't have 1994 Microsoft Word, can still see what letter Milton Friedman wrote to his colleague on this date or whatnot.
Oh, but I mean, I work at a company with like 200 people, and some of them have been there for 15 plus years.
Yeah.
We could use this archiving tool to figure out what random Excel spreadsheets they have somewhere on their disks. It's like you just described a problem that's really applicable to just computers everywhere. We generate digital stuff, right? Cruft, and we don't even know what we have. Yeah. That's a pretty interesting set of problems.
So, and I think that's generally where we gravitate towards for our OCaml software is, do we want to transform something from one format into another format? Write a command line utility to do that. OCaml has the nice feature where the naive code you would write without trying to be clever is usually pretty fast. And that's actually one of the mysteries of the language, why that is, but it's something to do with the way they wrote the compiler. And if you do want to aggressively performance optimize, it's not that bad to do it in OCaml, especially compared to Haskell.
I wanted to ask about the Elucidations podcast. You've been doing that quite a while now. Is that right? When did you start?
Yeah. I started recording it in 2008, and then the first episode was released in 2009.
Wow. So Mike and I have only been doing this for like a year and a half. So we have a lot of lessons to learn. You've a huge, long tenure, and we're just sort of baby podcasters.
Yes, although you do put episodes out much more often than I do.
I wanted to tell our listeners about your show. When I discovered your show, I was like, whoa, this exists. There's philosophy and computer science and language together in one place. That's crazy. Like, that's cool. What can you just give us a couple of examples of what are some of the favorite episodes you've done on that show, if you wouldn't mind? Any of that?
Oh, yes, I like putting it that way as well. Some of the favorite episodes, and then we don't single anybody out as not the one favorite.
Yeah, that's true. I guess one of the worst ones people shouldn't listen to.
Here's some randomly chosen from among my many favorites. Oh, yeah. So I definitely recommend one that I often recommend to people it's episode 134 with Claire Kerwin. And the name of the episode is Value Realism, but the jokey topic of the episode, which I kind of prefer, and maybe we should have called it this, is ice creamology. So that's what they called her when she took her paper, when she presented her paper at workshops and conferences. It was sort of jokingly referred to as the ice creamology paper. But she tackles the question, if you like some flavor of ice cream, like, is there a fact of the matter about, whether the ice cream is good or not, that's objectively true or false? And she has a version of the view of the less popular view that yes, there is. So you are in fact, you can be correct to like mint chocolate chip in some objective way. And she ends up hedging it a little bit so that it's not exactly as hardcore as you might think it would be. But that's a very interesting episode. I think it's quite approachable. She's really good at explaining her view, not using lots of jargon and using examples that you can understand, such as mint chocolate chip.
That sounds great. I actually hadn't listened to that one. I'm going to go check it out.
Let's see, another one. I love the one. It's a bit older. There's some old ones that I really love. Let me mention. I did one with Quill Kukla. It's really interesting. Yeah. 59. See, I knew I was going to be off by one. So even in speech, you're always off by one. So this is a really cool episode with Quill Kukla, and it's about these like reproductive risk warnings that popped up in California. So you all maybe be familiar with them as Californians. Basically, it starts off with the story of this law. I forget, it's a proposition number or something. I forget the number of the proposition now,
65,
but it's
maybe.
Yeah, something like that.
With. Yeah.
And the original intention of the law was, hey, let's incentivize people to make products that are safer for unborn fetuses. But what ended up happening instead of the intended purpose of the law was people just started sticking these hedgy stickers on absolutely everything and not trying to make anything safer. And I visit California regularly since I have in-laws there, and I see these stickers around. Oh, this is Starbucks and everywhere, and so they just schlepped a sticker on everything. And what Kukla gets into, I think, really brilliantly in that episode is that these since these stickers are on absolutely everything, they're providing no actionable information whatsoever about how to manage the risk decision. So Kukla really goes into he uses this as a jumping off point to think about, like, how are we asked to reason about risk when consuming products? That I think is an amazing,
considering products, you go into parking lots here, you go park in a parking garage, and there's a sign on the wall that says this parking garage has, chemicals or fumes that are potentially noxious to reproductive health or other health. Proposition 65 warning, and you think, the parking lot? What am I going to do about that?
Yeah, let's just not go to parking lot. And then they also tie it to history. So one of Quill's previous books is on the history of motherhood. So they tie it in really interesting ways to like this long history of like sequestering pregnant women and not letting them like basically ever do anything. And they sort of view these stickers as sort of an outgrowth of that because they're trying to scare pregnant women into retreating into the house and stuff.
Yeah, padded rooms and stuff. You'll be safer here, type of thing. That's really interesting.
Anyway, Quill's explanation of all this is far better than mine, but I thought that was a fascinating one. And then one other one that I would recommend, episode 50 with Greg Salmieri on the name we gave it was The Aristotelian Good Life and Productive Work. But this episode is about how Aristotle had sort of a condescending attitude about trade type of work versus fancy intellectual type of work. But he also sort of had a kind of respect for craft work that was so both things are kind of true of Aristotle. And the argument is that his snobbishness about craft versus fancy intellectual type of work kind of persists into the modern era. And in Aristotle's case, it was based on this very strict and absolute and kind of horrifying division of labor between slaves who would do, grueling work 100% of the time, and fancy people who would do grueling work 0% of the time, just hanging out, contemplating reality all day. And then Greg's argument in that episode is that the modern version of this is that we are our own slaves during the week, and then we are the aristocrats with absolutely nothing to do on the weekend. So what this thing where there's a division of labor between two classes of people in the ancient world turned into a division of labor of parts of our lives in the modern world.
So work for the man during the week, and then podcasts on the weekends.
And the podcast.
So this is, of course, a music podcast about software. And my understanding is that you actually make playlists related to the classes you teach. And I've been listening to a couple of them. I really like the grunge one, and I really like the one with like Gil Scott Heron and Stevie Wonder and
Oh
Earth,
yeah,
Wind and Fire.
yeah.
So tell us about those and how you use them.
Yes. So they originated during the pandemic, and I got the idea originally from this great professor and teacher named Brandon Feitelson. He did this crash course at the beginning of the pandemic, a Zoom course for people who are about to start teaching over Zoom unexpectedly for the first time and were panicking about it. And he gave us all these like really useful tips for making it work and so that people could really learn the material, hopefully almost as well or exactly as well as they would have in person. And he had this technique of just like playing music at the beginning of the Zoom meeting. And I found that it was an amazing way to just prevent this avalanche of where like everybody's like walking in late and kind of interrupting the meeting. So that's where it originated. I started just playing music at the beginning, and I would go like 5 minutes after the start of class, and the song would end, and then class would start, and then everyone was like there because it's 5 minutes late. And then I would also play music during the breaks. And then when we moved to in person in the spring of 2022, I think it was, or actually no, it was the fall of 2021. We moved back into in person. My TA said, "Oh man, I love that music." Well, actually, when my TA took the class, it was that Gil Scott Heron and Stevie Wonder and stuff playlist. He was like, you gotta keep the music. You can't stop playing the music. I was like, yeah, interesting suggestion. So I just continued to play music during class. We have an AV system that I use to do lectures with, so we can just use that same thing to play music. So I play music as people are walking in. I have them take 2 breaks in the middle of the lecture, and then I also play everybody out with outro music as they drift out of the room.
That seems pretty cool. I didn't have that in college. We didn't.
And then at the end of the quarter, I make everybody a Spotify playlist. Which, even though streaming is against my religion, it's the one thing I use Spotify for because I recognize that the youth only want to listen to things on Spotify. I'm definitely I'm absolutely obsessed with the 70s. This is a decade. I was born in 1980. It's the period from immediately before when I was born. And I have kind of a question for Mike, actually, because I know you mentioned that you kind of burned out on yacht rock, which was the first playlist that I sent you. You kind of burned out on yacht rock when you were young. But I'm curious, like, what is it about the 70s R&B that, which was maybe a little bit earlier, but approximately the same time period that led you to not burn out on it?
I think it's partially because I was listening to the wrong radio in the 1970s, so I didn't hear Stevie Wonder nonstop, and I don't think I was even aware of Gil Scott Heron. I did hear a lot of Earth, Wind and Fire.
He's so amazing.
Yeah, I actually have this. I have this playlist that I made myself called "The 70s That I Missed," because when I was
I'd like to see that because I wasn't alive then, so I've still missed some stuff, even though I'm scouring the internet aggressively for everything. Yeah.
So that was like mid 70s to late 70s was sort of my junior high school years, and what the radio in my Midwestern area was playing was Bob Seger, Led Zeppelin.
Not as much meters and stuff.
Yeah, so I was unaware of the Ramones. I was unaware of the Sex Pistols. I was unaware of New York Dolls. I was just all sorts of stuff.
Yeah, even though it's the same time, but it's not the same radio stations. Yeah.
So
that's fascinating.
I just made this list. I started this list several years ago, which is stuff that I wish I had known about in the 70s when I was 15.
The funny thing to me, as somebody who was not actually alive then, is that this is going to sound ridiculous, but it's nonetheless the way I feel. All 70s music kind of sounds like it was done by the same band, the 70s. The 70s is the band. And that includes reggae, punk rock, a light rock, the 70s version of metal, which is nothing like metal that came after, hard rock, Joni Mitchell type jazz rock. All of that kind of sounds like it was the same.
Another one that comes up for Eric and I is I'm having a senior moment here.
Sabbath. That's for me though.
You'll Big Star. I can think of as the replacements.
You introduced
Big Star. It's the 80s and 90s, isn't it? Or I have the era wrong.
So Big Star was this band. They put out. I guess they put out three albums. Yeah, it's Alex Chilton. Yeah, Alex Chilton was already kind of a well-known former from the 1960s. Yeah, he had done this. He had this big hit with the Box Tops in the 60s, and then he started this band in the early 70s.
Oh, that's cool. I did not know they went back that far.
Yeah, and so this music, like the first two albums, see, it's number one record and number one record in Radio City. They were so influential, and you hear hints of them of like 1980s alt rock. REM was influenced by them. The Replacements have a song called Alex Chilton. So all these bands that are now sort of legendary, influential alt rock bands of the 80s and 90s are had this connection back to Big Star, and I wasn't even aware of them until probably college. So
that's funny. I always thought of Big Star as the same era, like the 80s. Yeah, but I did not know it went back that far. I will have to I'll have to investigate some of this.
So, Matt, I feel like the topics you've introduced us to, they're like our ability to get into those is so cursory. It's like you've given us a whole universe of stuff to go out and read about, with generative grammar stuff and Frigga and composition and functional programming. Like, I feel like after talking to you, I have a long reading list.
And that's exactly what it felt like to me when I first discovered computer science. I was like, what? There's the classics of like Friedman and Felissen, and like, what even is this? Like, this is so weird and interesting. And listening to your show, I've never heard of, probably 70% of what you guys talk about on the show. And you guys give me some really cool homework to go do afterwards.
That's quite a compliment. I appreciate that. Thanks so much, Matt. Well, it's really been a pleasure having you on the show today. And listeners, I encourage you to check out Matt Teichman's podcast, Elucidations. It's an interesting show, a lot of great topics and a lot of great guests on there.
Thank you so much.
So thanks so much for coming on the show today, Matt. Great to have you.
Likewise.
And this has been Picture Me Coding with Eric Aker and Mike Mull. And we will see you again next time.
See you next time.
Bye.